I'm going to speak with you about 5 open source security tools I think that all developers should know about. So first thing first, most of the developers that I know doesn't really care about security, at least not the first thing, right? So when they say about if their code is secured, most of the time they say, not me, I don't know how, or something else doesn't really relevant. And so why does developers need to know about security tools? So we believe in a term, it's a relatively new term called minimum viable security. Like you have minimum viable product, probably you all know about it. So we think that like the product, it should be also in security. You have to start early. Don't wait for a breach to happen or for the CISO to come and start asking questions or for the company to have to do some compliance like SOC 2 and things like that. You have to start as early as they can. And shift left. So I'm sorry, I've heard it a lot of time in this convention. So I think that this is the future for developers. I mean, up until years ago, developers needed DevOps teams, to start servers, to do a lot of ops operation. Now they can do it by themselves. They can raise Lambdas, servers, whatever they need. Also in QA, they can create end-to-end tests by themselves. So I think the next thing is security. There are a lot of companies in the recent years that are starting to do this shift and give the developers the power to secure their code. So with a lot of power comes a lot of overhead. So they have to do it iteratively, not doing all at once. Let's say they didn't start early and the project program is running for years. If they want to do it now more secure, it can take them a lot of months to do it. So we're talking about doing it iteratively. Next thing is, why do you need to secure? So those are just few of the categories you need to secure. You need to secure your data to protect from any secrets to being leaked. You have to secure your libraries you're using, the infrastructure for cloud infrastructure and everything else, your containers, and runtime scanning. So how to choose. So I told you that in JIT, we want to help developers use those security tools. So actually research and invested a lot of time to research different tools in different areas, all the areas that I showed you before, and also in different languages. And I won't show you all the spreadsheet with all the thousands of points. And I'll get only the 3 main things you have to consider. So the first term is accountability. You're searching for a dependency check for Python, start looking for an open source tool for it on the web, get to GitHub, you see a couple of options. So you have to check the stars, how many force it is, how many watchers. Is it owned by someone private or by a big company, even a security company? Does it have a lot of contributors? Does it qualify by OpenSSF? Is it maintained? Was the last update a year ago, month ago, or days ago? And the licensing, is it really free? I mean, is it MIT, Apache? Do you have any rate limit? You get only some of the data free, but then if you want to see explanation about the vulnerability, you have to pay. So this is the first thing you have to check. OK. Next thing up is usability. So this one gets even trickier, because here you have all the data, you can search everything. Now you really have to try it. So try it. You can, if it's got a good documentation, you can run it locally. You can maybe use a Dockerfile to run it. Maybe it has some plugins to IDE or CI actions in GitHub or Jenkins. Does it configurable? Does it need files or flags to run it? Is it easy to add all those flags? And how does it output looks like? Is it a JSON file that you can handle technically? Is it easy to understand all the parameters? Like if it found a vulnerability, does it show you what it is and explain all the details? And the last part is actually the hardest part. You have to actually run it and see the results. So you can test it on your own repos, on Goat repos. So here we have actually some cybersecurity expert, better than I am, that actually check them on Goat repos and see if it has a lot of false positive or false negative. And does the severity level is accurate? I mean, maybe it shows everything is critical, but some of them is low. So it's also a lot of overhead to the developers. Does it have a good coverage? It can be on file types or maybe just more databases that it connects to and get more CVEs. So that was the part. And now, after we discussed about why, what, and how, let's start and deep dive to each one of them. So secret detection. OK, I'm talking a bit fast. We'll slow down. OK, so secret detection mission is to find secrets, passwords, even credit card numbers, API tokens, all kinds of secrets that you don't want to get to the web. So by the raise of hand, who knows someone else that pushed a secret to GitHub? Someone else, not you. OK. So it happens all the time. Not to me, of course. Someone I know. And we checked 3 different tools for secret detection. So we checked GitLeaks. Actually, a couple of days ago, we announced that it's going to be a company. It was by Zachary Smith. And it's going to be GitLeaks company. So I updated. We checked Detect Secrets by Yelp and Git Secrets by AWS. All are great tools. And we did all the checks that we talked about. And we decided to go with GitLeaks. I gave you the page from GitHub. You can see it has a lot of watching and forks and so many stars. And it was updated a couple of weeks ago. You can run it all so many options. I mean, directly for your computer. It has the CI action. I actually think that now the CI action you have to pay for, now that it became a company. But you can still run it free locally and in Dockerfile. It has a good config file that you can add more rules, more regex, if you have secrets that you know how they look like. It's very accurate. We saw that it found a lot of our secrets in our growth repos, not the real secrets. Of course, we don't have them. It runs on all file types that we checked. It can be a text file. It can be Python file, Terraform files, everything. And it found a lot of secrets from different types. I mean, AWS account keys, GitHub account keys, all sorts of secrets. So I'll show you just an example of how it looks like. So this is an access key for AWS. And if you run it, simply writing the command at the top, it founds the secret, and it also tells you the rule type. So this one is AWS access token. Great. OK, the second category is dependency check. So what's the mission? To detect open source component with known vulnerabilities, even if it's the first packages you use or even deeper packages that they use themselves. So we checked here specifically for Python. We are design partner 0 for our company. So we were writing Python, so we checked on Python. And we checked safety by PyApp, Jake by Sonatype, and dependency check of OWASP. All were very good, and we chose OWASP. Also, it's very, very common tool to use. It also passing the OpenSSF. It's very updated, probably 12 days ago, since I took the screenshot. And you can run it also in Dockerfile from the terminal. It's a Jenkins plugin. I put it in purple because I don't want to put it in red so you don't think it's vulnerability. But not such a good thing, it doesn't find the dependency tree. So for Python, it doesn't really matter. But the dependency check also can run on Node and on Golang. And they can find you a library that you use deeper, but it doesn't show you the tree of what was the first external library that you used. So you have to use some other tools to get the tree and tend to cross between the results. It's very accurate. It checks the vulnerabilities both in NVD data and OSS index. It runs for Python. It runs actually not only on the requirements, also runs on zip file or metadata file, other places that can have Python dependencies. And it runs, as I said, on multiple languages and not only Python. Some of them are in experimental mode. So actually for Go, we choose Nancy. And I won't discuss about it, but it's such a cute logo, so I put it here. So yeah, you have to really check for each language that you use if it's good for it or not. For Python, we found out that yes, but not so for other languages. It depends and they keep processing it and keep updating it. We will see updates all the time. Okay, so an example, I have this big requirements file with only one library, requests, and you see all the output, but I'll zoom in. So it found that it has a vulnerability inside it. It tells you the CVE from OSS index. It even gets a score. And what happens with this package, actually this one sums it up, insufficiently protected credentials. And you can even go to the site and get more data from OSS index and for more site. Cool. So point number 3, infrastructure misconfiguration. So what's the mission here? So we want to detect misconfiguration in infrastructure as code before it hits the sky, reach the cloud. It can be missing encryption, too broad permissions. Maybe you're not logging, which is actually essential in security, or not using other mandatory things you should use. You have some default ports or any other default values that you shouldn't use. Let's check the picture. It helps me to slow down, so it's OK. OK, so we checked TFSec by Aqua, Kix by Checkmarx, and Checkov by Palo Alto. I think all have a booth here upstairs. All were very, very good tools, and it was really hard to choose. We go with Kix after a lot of testing. Also very, very strong tool by Checkmarx. Very updatable, stars and everything. And it can run on multiple file types. It runs on Terraform files for the AWS, CloudFormation JSONs for Azure and Google Cloud as well. It has powerful queries, I think more than 2,000 queries you can see on the website that it runs and scan and check if there is a vulnerability in your code. It does a nightly build, so it can get updates all the time. And the non-fileable scan is actually a line from their output. So usually, when you run it, you get a JSON file with all the data and all the vulnerabilities, even if it didn't find anything. But if there weren't files to scan, meaning there were JSON files but non-CloudFormation JSON, it gets you a text file with this output. So it's not the only case. There are some kind of cases when it not gets you the output you're looking for. So you have to handle it yourself. And here's an example. So this is Amazon Elastic Block Store, and this is the config for it. And I'll zoom in. It found you the severity in medium level, and it's essential to use encryption, and it's not enabled. I want to add something else. Compared to Checkov, which was also good and also gave us a lot of results, Checkov didn't give us the severity level. And this can be very overwhelming to get 2,000 vulnerabilities without any severity level. You don't know which one are more critical than the others. So this is one of the reasons that we choose Kix and not Checkov. OK. But both have very good false positive and false negative scores. OK, container scanning. So the mission to find vulnerabilities in your container images, in the Docker files. So we tested Trivy by Aqua, Claire, and Encore. And we chose to go with Trivy. Also, they have a boot upstairs, I think, of Aqua. Also, a lot of stars and forks, and it's very updatable, maintainable. And it's very, very easy to use. You straight out of the box. It's very accurate. It runs on multiple OS packages if your Docker file runs in different packages. And it also detects secrets and infrastructure as code vulnerability. So why is this line in purple? Because for Trivy, it's good. It does a lot of things. But actually, it is better for Docker files. And we use the other tools for secrets and for infrastructure as code. So if we use Trivy as it is, we will get actually duplicated findings and vulnerabilities from all the tools. So you have to configure what you want to get from each tool, if it is configurable. So I didn't add the Docker file, but I ran it on a Docker. It found 3 vulnerabilities. 2 of them is because buffer overflow, because of a long path name. And the last one is runtime. So runtime scanning, you need to check your web application, even your APIs, while they're live, up and running. It's also called Dust. So we checked between ZAP by OWASP Foundation, Nikto, and Arkini. I think actually they're already deprecated. And ZAP is a well-known tool. I hope you already know, have heard about it. I think it's running for 12 years now. And it's very, gets a lot of releases, a lot of contributors, passes the OpenSSF. It can be run in two types, full scan Docker. You can actually install it as an application, and it has a UI, and you can figure out everything. It's very, very extensible. So it's got a marketplace. It's got a lot of plugins. So if you want to deep dive in it, there's a lot of work you should do to add more plugins and to use it better. It's very accurate. It has a lot of features. It checks for SQL injection, broken access, cross-site scripting. It does fuzzing, authorized and unauthorized access. So many, many tools and many things it can check. OK. So here is just an example of finding that it found. The content security policy, the header is not set, and it explains you the reason why it's a problem. It gets a risk score. I don't know why it's both low and medium. OK. So I'll show you a quick demo of using only 4 of the tools, the first ones, and what can go wrong. Whoops. OK. So here I have my repo. It's public. And it's got a Terraform file. Using DynamoDB. I have here a Docker file with some passwords in it. We've got a Python file to run everything. And a requirements with some vulnerabilities. OK. So I just configured a GitHub workflow, called it security YAML. And you can see here, I will zoom in. OK. So I just wrote all the tools that we discussed about. It runs parallelly in different jobs. So secret detection, this is all it has to take in order to run. Actually, it runs only on the last commit, unlike the others, which checks all your different branch. I'll discuss about it later. Dependency check. So this is OWASP dependency check, and everything you have to pass it in order to run. So this is for running on Python. OK. Infrastructure as code. This is Kix running on the Terraform file. Told you it can run also in other file JSONs and a lot of things. They actually also added option to run on Docker, so you need to check it again compared to Trivy. But still, we're using Trivy for checking containers. And that's about it. OK. So I will add a GitHub token, because I love secrets. I saved it here. And I'll create a new branch. OK. So this is actually pushed my changes. I don't have to create a pull request. And it started to run all the tools. You can go in. In the meanwhile, I'll create a pull request. OK. So this is the secret scanner by GitLeaks. you can see how it works. And it found, leak was found. It tells you the rule. It found out that it's GitHub password. This is just the regex for how GitHub secrets looks like. GHF and numbers. Okay, dependency check finished. Okay. So you can see it ran a lot of checks, and it tells you that it found the CVE. You can go to the report also to find it. They finished really by the order. And this is Kix, and it found a lot of things of different severities. IAM access analyzer not enabled, S3 bucket logging disabled, higher severities Dynamo table not encrypted, MFA delete. So you can see it found a lot of things. Too high severities, it gets you a conclusion at the end. And last one, it's still running. Okay, so part of the problem that some of them can actually take a long time. Actually, I'm surprised it's Trivy. Usually it's more Kix because it reaches database to get information, and also dependency check, it needs to be updated all the time. But let's give Trivy some chance. Thank you. Okay, so it took time because it needs to update the DB every once in a while. And it downloaded the DB. And it found four high vulnerabilities. And it explains you the reason why. Zoom in. Okay. So I'll go back to the slides. Okay, so I show you how to run everything, and we discussed about some difficulties that we have with them. I mean, not all of them, most of them are pretty accurate, but you have to add, some takes time, some have different output files. So you have to handle each one of them and see how to use it. I still recommend, if you're not using any of them and you're using Python or any other tool that we discussed, to try and see it for yourself, to just add him and see if it finds vulnerabilities. Another issue is, unlike Git leaks, they run on all the default branch and find all the findings since day one. And it also can be very overwhelming to the developer to just write his small PR. I didn't want to see all the other files that he didn't touch. So we at JIT actually want to do an orchestration of those tools and to help you use them very easy and much faster. And those are some of the tools that we're running. So it goes for different languages and different technologies. Prowler, for example, is for running checks to your AWS cloud. SamGrep is for static analysis for JavaScript. Bandit is static analysis for Python. GoSec for Go. We discussed about the cute logo of Nancy. And, sorry. And we also added branch protection, checking your branches at GitHub to see if you enabled branch protection, and more other tools that we're using ourselves. And I'll show you our tool in a minute, but these are some screenshots. Let's just see them. Okay. Okay, so I already enabled a plan. Let me zoom in. So I want to check on my assets. I want to check static analysis, dependency checks, secrets, containers, and infrastructure as code. You have service catalog to add more tools. You can see by plans, if it's SOC 2 or OWASP serverless top 10, by categories, and you can add more tools and more features. Some of them, we're still in beta mode, by the way, so some of them are not enabled, but you can use most of them. And I already committed the plan, and I already added my repos. So these are all the vulnerabilities I already had on my default branches. So we do think that in these pages, not every developer will go and look inside, because this is more for a security champion that want to go deeper and find old vulnerabilities, and he can decide what to do with them, to assign them to a team or to a person. But once someone created a PR, so this is for the developer, we're actually telling him where he added, this time, a secret, where he added vulnerability, and we show it as a comment on the PR. And if he merge it anyway, it depends if they enabled branch protection by us or not. Oh, sorry. So only then it will go and appear here in the finding page. So I'll give it time to run. And I think